this homework assignment has two problems. Problem number one, which is homework assignment 1_1. And this is your class naming conventions, okay? Moving forward. For problem number two, your class is homework assignment 1_2, okay? And the same thing applies to other assignments. Like say homework assignment 2_1 for homework assignment 2, the first problem, and so on and so forth. And accordingly, you'll have to save your solutions, as you know, in intro Java. The name of your Java file has to correspond to the class name that you have in your code for your console application. So just make sure that you name your file accordingly. Do not ever combine solutions into one. So in this homework assignment, you have two files. One is homework assignment 1_1.java, and the other one is homework assignment 1_2.java. Do not combine both. Each file should have its own static main. Okay, so this is your entry point, and here this is your entry point. So because this is your first assignment, I took the liberty to kind of write down the API documentation for you already, and I also did some example use cases in the main for you. And of course, moving forward, I'm probably not going to have any of these here. Now, your responsibility is to making sure that whatever is in red here, or the target, either the target function, target class, is your responsibility. You're going to make sure that that this part is correct. Now, as far as what you like to have in your main, which is essentially just a list of test cases or test runners that that you may insert on your own. I don't really grade it. I don't really look at this part. What I care about is that your homework compiles, and it will compiles only if this thing is saved in the same name as your class name. So your entry point, which is the public class, calls your inner class. So in order for this store, and this is also from your intro Java too, in order to fit two classes into one file, you got to make sure the entry point is a off-scope public, and the other class does not have any public in front of it. And this is it. If you put a public in front of this class, MaxStack, you're going to run into compilation errors. So that said, the very first thing before we get into it is to make sure that, and sometimes you can do this yourself too, is to make a copy of this and go to a online IDE such as this. I use this a lot, or if you have your own IDE set locally, you can do that. But the very first thing is just copy and paste it, because I don't want you to type this in all by yourself from scratch, because if you do, sometimes students misspell like MaxStack, and they'll make this M lowercase and things like that. And this will actually invalidate your solutions because it will not pass AutoGrader, because AutoGrader always looks for homework assignment, whatever this number is, and test your code, right? So in this case, your code is the entire MaxStack. Okay, so in order for this to work, and here's a limitation too, if you're using Replit, the class is called main. With other IDEs, you may not have to do that, but with this, since they are quote unquote saving the files for you in main.java already, you kind of modify this to main. But this only applies to the very beginning. Now, I'm not asking you to use this online IDE to code your solutions, because this is online, and you want to be offline as much as possible, okay? And obviously, you want to make sure that every one of these single lines compiles. So I'm just going to get rid of the your code here to make sure that the syntax and everything else is correct. And this one doesn't have a return. So in order for this to compile, I'm just going to type something in there. You know, this is not correct. Okay, so this is just for illustrating purposes, and I wanted to make sure that I can compile this for you. So hit run. This takes a little while, but right now this is working as is. So I want you to use, like, moving forward, if you can, just make sure that you have entire template in a syntactically correct format before starting coding yourself. So that would be kind of my recommendations, and you pretty much do the same thing, obviously, with homework 2 as well, 1_2. But let's go back to the homework problem here. So basically, what you're asked to do in this problem is to write a wrapper. This is a class wrapper called MaxStack that wraps around Java util.stack. So you have to import this. That's why you see this here. The same thing with problem 2. So problem 1 and problem 2 are basically the same, with the exception that the first one is looking for the max and the other one for min. But the format is similar. So let's take a look at what this is. You're asked to write implementations for these 4 inside this MaxStack class, right? There are 4 methods. First one is push, second one is pop, top, and then the last one is called get max. So push, pop, and top are exactly the same as what you would expect in Java util.stack. So make sure you read up on the documentations. You can go to Oracle website and check for it. Just Google this. You'll be taken to the SDK, either standard editions or enterprise editions in Java. You read up on these, and that's basically what you have here. I basically am also writing out the specs for what this function is doing. So anyhow, so your MaxStack is responsible for sending value into the stack, popping the value out of the stack, and be able to also peek into the top of the stack and see what it is. So just follow the instructions there, the description of for each of these methods, as well as get max. So get max is a method that retrieves the max elements in the stack in constant time. Okay, so in constant time means that that you can either use a hash table. In this case, you don't need to use a hash table. Retrieval of any elements from hashes constant time, or simply just keep a global maximum variable, and that global maximum variable keeps track of the global max. And that allows you, and if you just return that max, global max, that is constant time, because you're not doing any operations other than just returning it back to the caller. So that is what I meant by in constant time. Okay, so with that in mind, let's take a look at an example here. So I'm going to annotate this. Let's just take a look at the several examples here. So this is your stack. If you were to push, in the beginning, there's nothing in there, right? So if you were to push first elements in, which is -2, you're going to have -2 here. So remember, a stack is LIFO, right? Last in, first out. So you can visualize this entire LIFO on a horizontal direction, but I chose to have this in vertical direction. So the growth of the stack actually goes up from the bottom to top. So with that said, when you do push 0 again, this 0 goes on top of it, right? And then 0 and -3 being the third element. And then this function, then this method is invoked. This method says get max. So basically, you'll have some sort of global counter that keeps track of the global maximum here. So if you're at -3 location, which is your top, your all-time max is 0, right? It's actually right here. Okay, it's right here. That's fine. Now, when you pop something next, so the next thing is to pop 0.3. If you pop 0.3 and do a top returns 0 because 0 is the very top of the stack. And then if you do a get max again, it returns 0 because 0 is still your all-time max. Now, I just want to be super clear. This will work most of the time, but you got to think in terms of the situations where what if you your max is the one that is being popped right now. Then how do you keep track of the previous max, right? How do you know what the previous max was? Because if you just have one single variable keeping track of the all-time max, what about the second max, the third max, the fourth max, right? So you're going to have to kind of figure out a way to keep track of these things in this particular problem. So my recommendation is just focus on problem number 1, and don't worry about problem number 2 until you finish your problem number 1 and everything's working to spec, and then you work on number 2. So number 2 is exactly the same, but in reverse order. Instead of looking for max, you're looking for min. Okay, so that's essentially what you're given here. If let's see if there's more examples here. So I kind of took the liberty of writing down just a random one, right? So this is what you would kind of expect, you know, how you would test your own code. But whatever you chose to do in here is completely up to you. You can have your own implementations. I do not ever look at this part at all, but it has to exist because this is how you provide your entry point and be able to test your MaxStack. So your responsibility to make sure that your entire MaxStack class implementation plus the method is all correct. Okay, this entire part is your responsibility. Okay, a couple things that I wanted to say is, yeah, if you start thinking about how you can keep track of basically all-time max, but second to max, third to max, and fourth to max, you have to think about a mechanism that will help you achieve this. There's a couple ways to go around it. One is just to use your single Java util stack, but there is a workaround that you can explore. And the other one is just use another temporary stack if you like to keep track of the maxes. Same thing with the minimum. So that's pretty much it for problem number 1. There is for each of these problems, there's going to be constraints and assumptions. Just make sure that you read through these constraints and assumptions and do not make your own assumptions. One of the assumptions is if you have an empty stack and you perform pop, wouldn't that cause empty stack exception? Yes, it will, because you're using Java stack, util stack, and Java API throws the empty stack exception, which means you have to handle that. But I just wanted to make clear for this class, error handling is not the core or focus for this course. So I would not give you a use case that is going to cost you, that's going to lead to an empty stack exceptions on your POP. So do not worry about it. But whether you want to use it or not, or define your own error handling in code is completely up to you. But I would not give you a use case that would involve empty stack exceptions ever. So this applies to any other sort of edge cases. If something it is not assumed, and that may cause some sort of exceptions, you can trust that that I will not give you I will not give you that use case in a test runners inside the autograder. So so that is problem number 1. Problem 2 is exactly the same as the previous one, but this time you're looking for all-time minimum. So you're gonna have to do the same thing and just make sure that the retrieval of minimum elements in the stack is in constant time. If you use a temporary stack, the retrieval might not be in constant time. So you gotta be careful. The best way to do it is to have some sort of global value that you can just return. And that global value basically tells you what the all-time min max